Let us read the first question. A front wheel driven car is stuck in mud. When accelerator is pressed, then what will happen? First of all, let us imagine when the car moves in this direction, we can imagine that the wheels will rotate anti-clockwise. And this is the front wheel driven car. So when you press the accelerator, the front wheel will try to rotate in anti-clockwise direction, like this. But because of mud, it will just keep on rotating there itself. It can't go forward, but because there is no sufficient friction, and that's why we can read the option number A. The car wheels will spin clockwise. No, the car wheels will spin anti-clockwise. This is correct option. The car is stuck in the mud because of lack of sufficient friction. Because of lack of sufficient friction only, it is stuck. So this is correct. And D option says that when the wheels feel the tiny friction on the front wheels act in forward direction. So if the wheels were not stuck, then what would happen? This car will move in a forward direction. That means the frictional force will act in a forward direction, right? So if there is a sufficient friction, then the car will move in a forward direction. But if there is a not sufficient friction, very less friction will act still in a forward direction, right? So that's why option number D is also correct. Tiny friction of the on the front wheels act in a forward direction. So B, C, D are the correct options, and A is the wrong option. So we have to select the incorrect option. That means option number A is the correct answer. Let us read the second question. On a rainy day, a car loses its control when tiny pores in the tires gets filled up with water, and there is a good amount of water on road as well. This is similar to the carom board being filled with powder. So when we add powder on carom board, the friction between carom board and the coins is reduced. That means it will slip easily, right? So can we read the options now? The A option says that the car loses its control because when the person steers the steering wheel instead of car turning, it keeps going straight. So this is the correct option because when he is turning the wheels, uh, there is no friction at all. That means if there is no friction in horizontal direct, I mean there is no friction in horizontal direction, uh, then how can the tires turn? Because of the friction only, it will turn. So now there is very less friction because of the water in the tires, and there is enough water on the surface. So it will there is actually no force acting on the car. So when the no force is acting on some object, what will happen? It will continue its uniform motion. So friction is very less, almost negligible. So net force is zero. That means the object will continue its uniform motion. That means it will keep on going straight. A is correct. So B is saying the car will lose control because when the person keeps steering wheel straight, instead of car going straight, it starts turning. Why would it turn automatically? It's going nicely in a straight manner. If there is no friction, it will just keep on going straight. It won't turn. So B is wrong option. C says the car loses its control because when the person steers the steering wheel, the car turns as it's supposed to do. Now that will happen in a normal condition. On a rainy day, it won't happen. The friction force is non-existent on a rainy day, so it will move in a straight line. It won't turn as it is supposed. So C is wrong. The D is the car loses control because when the person keeps the wheel straight, the car keeps going straight as it's supposed to do. Now, on a rainy day, if we are not doing anything and the wheels are straight, it will go in a straight line. It will go in a straight line. But will he lose control because of that? I wouldn't say he will lose control because of that because he's just going in a straight line. So unless some emergency comes and if he applies brakes, then if the brakes are not work, I mean even if there is no friction, so that effectively the brakes are of no use, then he can lose control. But generally, if there is a no situation of applying brakes, then it will just go in a straight line. So he won't lose any control. So option number A is correct. Other three are wrong. In the third question, we can draw the free body diagram of the table. Now the table has a sufficient friction. The mu is very high. This is the coefficient of friction, or I can just say friction is higher. So the table won't move. Now the person is pulling the table on the left hand side. I can represent that as a force on a table due to person, and it is a frictional force because when a person actually touches the table and pulls it, That means the surfaces of hand and the table are interlocked, and that's why it is frictional force. So let us read. The friction force on a table from person hands is towards the person. The person is here, right? So this friction force is towards the person. So the first A option is correct. I mean the A point is correct. So B says that friction from a person on a chair is towards the table. Friction from a person on the chair is towards the table. See, now he's sitting on a chair. I would just draw it like this. He's sitting on a chair like this. Okay. Now there are wheels to this chair, some wheels to this chair. So when he applies the force on table, that is due to the person, because of reaction, there is a force on this person due to table. That means this this chair with wheels and person will move in that direction. So basically, if we just draw the free body diagram of the chair is moving in that direction. That means there is a force in that direction due to person on chair. So friction from a person on a chair is towards the table. It is towards the table. So B is correct. Now C says the friction on table from ground is away from the person. Now this table is not moving. That means this friction should be cancelled out by some other friction here, which is the friction force on table due to ground, and it is away from the person. So that's why C is also correct. Now instead of chair, if the table had wheels, then the table would have moved and not the chair. Exactly. So if the this is the person, we can just draw this again. This is the person, it has no wheels and the friction is high, then this won't move. And if the table has wheels, so there is no sufficient friction in backward direction, but this is pretty high force on table due to person, then this will move. And because of the high friction, this friction will cancel out this force on a person due to table, and it will become stationary and the table will move. So instead of the chair, if the table had wheels, then the table would have moved and not the chair. So D is correct. Now E option says the friction is able to prevent sliding on a ground but unable to prevent wheels from rolling on the ground. So that's very nice thing about rolling actually. So as you can see, there is a force, external force, and because of this friction here is actually called as a static friction. It is preventing the sliding. But what will happen if this wheel is there and if I apply some force? Okay, now when wheel turns and when wheel rolls, uh, so the friction can't prevent the rolling. As you can clearly see that the friction can't prevent the rolling. So the wheel will still roll. So friction can prevent sliding, but it can't prevent the rolling. This object will still roll. Actually, the friction is necessary for this wheel to rotate. Can you imagine where there is no friction and we apply force like this? So this wheel will actually not rotate much. I mean, it can't rotate. So because if we want to turn a wheel, so we need a friction actually. Without friction, it can't roll. There has to be a friction. Otherwise, what will happen if there is no friction? Now, what will happen? Let us say this is point A, this is point B. After some time, it will just go like this. This is point A and this is point E. No rolling will happen if there is no friction. But if there is a friction, what will happen? If I apply some force, so this is point A, it will turn like this, let us say, and the point A comes here. This point B, the point B will come here. So it will turn. So we need some friction in that direction to turn the wheel. Can we imagine if there is a wheel and if you apply the force in that direction, it will turn like that, right? So we need a friction actually for rolling. So friction can't prevent rolling, it will roll, but friction can prevent sliding like this. So option number E is also correct. All the five statements are correct. So C option is correct. Okay, so in this question, there is a rope like this, and let us say this is a monkey. I can represent this block for a monkey. Let us say its mass is m. In the first option, it says that monkey climbs the rope and increases speed. That means acceleration is in upward direction. That means net force is in upward direction. What is the net force on this monkey? It is the force. It is actually the frictional force on the hands of monkey Static frictional force on hands of the monkey, I can write this as F M due to rope, or let us say string. Let us say this is string. So FMS, and the gravity is downwards. Then, as the net force is upwards, we can say that FMS, force on monkey due to string, minus mg, which is net force, is equal to mass into acceleration, because we know F net is equal to mass into acceleration from second law, Newton's second law. But anyway, the gravity is downwards. This frictional force on monkey due to string is upwards. That's why the monkey can accelerate upwards. And they are saying the force applied by monkey on a rope. Now, force applied by monkey on a rope will be downwards. It is a reaction. Force on monkey. Force applied on a string due to monkey. This is force applied on monkey due to string. This force applied on string due to monkey, which is reaction, which is downwards. But they are saying the force applied by monkey on a rope. So force on a rope due to monkey is in upward. It is not correct. It is in downward direction. So A is incorrect. Let us read the B option. In B option, monkey is stationary. That means the upward force on a monkey due to string is same as gravity. So Fms is equal to mg. So force on monkey is upward. So force on string will be downwards. This is the force on string due to monkey. So but they are saying it is upward. So D option is also wrong. So we have to choose the correct statement. Okay, let us read the C option. When the monkey is slowly climbing down and descending in a rope, force applied by monkey on a rope is frictional and is in upward direction. So when a monkey is slowly climbing down also now, if it is moving very slowly, that means acceleration is zero. That means net force is still zero. That means the frictional force on a monkey due to string is in upward direction, and they are saying uh, the force applied by monkey on a rope is frictional as in and is in upward direction. So we need the frictional force by monkey on a rope. So this is the frictional force by monkey on a rope. We can say that this is the frictional force on string due to monkey. It is in downward direction, and they are saying it is in upward direction, so that is wrong. So C is also wrong. So the D option says that when the monkey is slowly coming down, the same thing, acceleration is zero. So force applied by monkey on a rope is frictional as in downward direction. Yeah. So this is the force applied on this string due to monkey, which is in downward direction. So D option is correct. So answer for fourth is D. So we had to choose the correct option. So in this question, the wave is shown here like this. So this is A point, B point, C point, and D point. These are peaks, or we can call this as crests. And this is the 1, 2, and 3 point, which is trough. So the distance between A and C is called as one wavelength. Distance between two peaks is called as one wavelength. This is two times wavelength. So option number A is not correct. Distance between A and B, distance between A and B is more than distance between B and C. So this is not correct, because every distance between any two peaks is called as wavelength and it is same. So B is wrong. If Derek starts moving the ball up and down quicker, then the distance between A and B will decrease. So we know V is equal to F lambda. V is the speed of wave in water, which is fixed. Now, if we increase the frequency, that means if we are moving up and down quicker, that means frequency will increase. That means lambda will decrease. The wavelength will decrease. That means the distance between A and B will decrease. So option number C is correct. The D says the water particles travel from A to B. No, that is not correct. Water particles don't travel, they just move up and down like this. So option number D is incorrect. So correct answer for 5 is C. So in this question, we just have to know that the pitch of E sound is higher than pitch of O sound. So A option says that the sound of E is high pitched, that of compared to that of low pitch. So A is correct. Now B says that the sound of O is high pitched. It is contradicting to the A. It is wrong. Then the C option says that the person turns on the TV and hears the cow uttering moo, so it ends with oo. And when the increases the volume, pitch increases. See, when we increase the volume, the amplitude increases, the pitch doesn't change. Pitch is the frequency. So this is one wave of one frequency. I can draw the same wave with the same frequency with higher amplitudes. like this I can draw. So this is what happens when we increase the volume. The amplitude will increase, but the frequency will remain same. So C option is not correct. D says that if a person turns on a TV and hear cow uttering moo, when he increases the volume, the pitch decreases. No. So when he increases the volume, pitch is unaffected. Amplitude will change. So pitch is not affecting. It is not increasing or decreasing. So D is wrong. So option number A is correct. Okay, in this question, let us read the option number A. So this is a water bottle, and when a person holds it, let us say he's just holding the bottle in his hands, and the bottle is not falling down due to its weight. That means there is a frictional force acting upwards. So the irregularities of hand and the bottles are interlocked, and that's why there is a frictional force, static frictional force on bottle due to hand. So A option is correct. There is a frictional force between surfaces. When the person turns the bottle cap anti-clockwise to open the cap, so clearly the surfaces are sliding. So there is a sliding friction involved there. If there was a no friction, when you start to turn the cap, it will just keep on rotating. Then it won't stop. It is stopping because of friction. So there is a sliding friction between the surfaces of the bottle and the cap. Now C option says that water bottle is lying on a rough horizontal stationary table. So let us say there is a water bottle like this and it is lying on a surface. So there is no frictional force in any direction. This force is actually called as normal force, and this is the gravity force downwards. And they'll balance each other. They will balance each other. So there is no net force in vertical direction. So this object is not accelerating in vertical direction. In horizontal directions, there is no external force. So there is no friction. If you just say there is a friction acting, then there will be net force and it will start to move automatically. So it's not possible. So there is no external force and no frictional force. So friction is not there in the third option. So in C option, there is no friction. So C is incorrect. And in D option, a person moonwalking during the dance. So when the person is walking, he is moving in some direction. So who is applying that force? Ground is applying that. And what is that force? It is a frictional force only. The normal reaction due to ground will act upward, but the friction will act horizontally. And it will be a static friction because he is just, walking without sliding his shoes. He will apply, so his shoes will apply some force in backward direction. It is a static friction, and the ground will apply a reaction force on his shoes. So force on a person due to ground in that direction, and it's a static friction. So there is a force applied on this person due to ground. So D option is also correct. So in C option there is no frictional force acting. So C is the answer for this question. In this question, Newton is sitting below the apple tree, and the apple falls from the tree. So we'll read the option number A. Gravity acts on an apple when the apple gets detached from the tree. When it is hanging on a tree, then also the gravity force is acting on this apple. So the gravity force will act on this apple, its weight is mg, and the tension in this branch will act up in upward direction, and the net force is zero. That's why the apple is staying there. So even if it is hanging, the gravity is still acting. And option B says that as the apple becomes ripe, its mass increases. So this force will increase, and the tension can't balance that now. This branch is becoming weaker and weaker also, and the tension is not sufficient. So it will detach then and it will fall down. So this leads to moment in time when the gravity force exceeds this tension, and it will get detached and it will start to fall down now. Only force acting is mg now, and it will accelerate with acceleration g downwards. Okay. So option number A says that gravity acts on an apple when the apple gets detached, not when it is still hanging. When it is hanging now, still the gravity is acting. So option number A is actually incorrect. Okay, and the B option says that this weight will increase, and the tension can't provide it, so it will get detached and it will fall down. So B is correct. We have just said it. C says that the meaning of apple falling freely downward means that it is going down due to inertia without any force acting on it. No, there is a force acting on it. That's why it is accelerating with g downwards. Objects can't accelerate without force. There is a net force. That's why it is accelerating downwards. So option number C is incorrect. Because of inertia, an object can move with uniform velocity. It can't accelerate. It is accelerating. That means there is a net force acting. This is not case of inertia. Because of inertia, object will move with uniform speed or uniform velocity. Yes. So option number D says that apples of various shapes and sizes almost fall to ground is in same time because the same gravity force act on them. No, the gravity force acting on small mass m and capital mass M are different. This force is mg and this force is capital Mg. But the acceleration is force by mass, so mg by m. It is g. The acceleration in this case is force by mass, which is g. So in both the cases, the acceleration is g. So acceleration is same. That's why the time takes to hit the ground is same. But the same force is not acting. The force is higher here, but the mass is also higher here. So G is same. The force is lower here, mass is also lower here. So the G is same. And the G is same, that's why time to hit the ground is same. But in the D option it says that gravity force is same. It is not same, it is different. So D is incorrect. So only correct option is B. So the correct option for 8 is B. Okay, in this case, this is the experiment. So we have the bottle here, and let us say the atmospheric pressure is P naught outside. Inside also it will be P naught atmospheric pressure, and the temperature is T naught outside. Inside also it's T naught. Now what will happen if we put uh, some burning stick inside? The temperature inside will increase, and the gas will expand and gas will go out. So temperature inside is greater than T naught now. After some time, when we'll put the balloon. So after some time, the temperature will drop to T naught again. What was happened here? The air was gone outside, so the number of molecules were reduced to n minus n now. The temperature drops down to T naught here. So when the temperature was T naught and the number of molecules were n, the pressure was P naught. So let us say at some temperature T naught, n molecules are hitting the wall and the temperature is P naught. Now at the same temperature, less number of molecules are hitting. So the pressure is low now. So pressure is low inside, but outside pressure is still P naught atmospheric pressure. That's why the balloon goes inside because of the pressure difference. So let us read the option number A now. We have to select the incorrect statements. Fire extinguishes after some time due to consumption of oxygen. Yes. See, when you put the balloon, like this, so there is limited oxygen there and it is all getting used up. So after oxygen is getting used up, how can it burn? For burning, we need oxygen. So A is the correct statement. After oxygen is used up, the fire is getting extinguished. So B option says that only once the fire extinguished does the balloon starts going inside. So balloon, okay. So when the fire is getting extinguished very quickly, and because of the balloon, fire is extinguished very quickly, and then after some time, the temperature starts to drop down. The temperature has to drop down, then only the pressure will drop down. So only after the fire is extinguished, the balloon starts going inside. So B is correct. Now the C says that the balloon goes inside because inside pressure becomes larger than outside pressure. It's actually reverse. The inside pressure is lower than outside pressure. That's why the balloon is getting pushed inside. So C is wrong. Now D says that the pressure inside the bottle is reduced due to sudden reduction of air temperature. So yeah, we have explained it. The temperature is reducing from T to T naught, and that's why the pressure is reducing because the number of molecules are less already compared to this, and that's why the pressure is lower inside and higher outside, and that's why the balloon goes inside. So option number D is also correct. So which is incorrect statement? C is the incorrect statement. So C is the correct answer. So let us take the balloon here of a helium gas, and let us take a balloon of oxygen gas. So we know that the buoyant force upwards is same for both. We know the formula for buoyant force is sigma Vg. Sigma Vg. Let us say the volume is same for both of the balloons. Sigma is the density of air. V is the volume occupied by the object, which is same. So sigma V is same, and G is also acceleration due to gravity, which is same. So the force upwards is same. Now the force downwards is lower in case of helium because its mass is lower, and the force due to, I can just draw this as small force. This is a smaller force, and I can say that this is a larger force, capital Mg, because the mass of this oxygen is greater than mass of this helium. See, the volume is same, but we know that oxygen molecule is heavier. So if the volume is same, in the same volume, the mass of the oxygen will be higher. So that's why the net force is downwards for this oxygen, and it will come down. And the net force is higher. So net force is upward here. Net force is upward here because this upward force is higher compared to the downward force. So that's why the helium will rise and oxygen will not rise. So let us read the options now. A says helium gas inside balloon is at lower pressure as compared to the balloons. So it's not about pressure. So if this is the like lower pressure, then this balloon will be compressed. It's not deciding whether it is moving up or down. So A option doesn't decide that. Helium gas inside balloons more pressure as compared to the balloons filled with normal air. Again, the pressure doesn't decide that. Pressure just decides if the balloon is expanding or contracting. So C option says that atmospheric gas exerts more upward force on helium as compared to normal air or oxygen, let us say. No, the upward force is same for both. Upward force is sigma Vg, buoyant force. It is same. So C is also not correct. Now D says that gravity force from Earth in downward direction is less on helium compared to this other gases or normal air, because normal air is more heavier. And that's why this is not balancing this upward force, and that's why there is a net force and it will move up. So this is the correct reason. The gravity force on this helium is lesser. So D is the correct reason. So option number D is correct for this question. Okay, in this question, at higher altitudes, the atmospheric pressure is lower as compared to atmospheric pressure at flat points. So let's choose incorrect statement. A option says that the air near Earth's flat plains is pressed to Earth's surface by air layer above it due to gravity. So if we just draw this air layer and this air layer, it is clearly pressed downwards. So it is a correct statement. B says that air doesn't experience any gravitational force from Earth, otherwise all air will come down near the Earth's surface. It's not like that. Air will experience a gravitational force, but air also experiences the buoyant force also. We know the buoyant force works in fluids. So if we just think about this region here, so the forces on this region is gravity force, and the upward force will also at sigma Vg, and this will stay there. So gravitational force is still acting. So B is wrong. A balloon rising up will keep expanding more and more. Yes, because when the balloon goes up, what will happen? The inside pressure is same, but see what will happen. Yes, so this is like a balloon here near the bottom, and the balloon at the top will expand now. What will happen? Why? See, so the balloon near the surface of Earth will have the inside pressure as P naught, atmospheric pressure, and when it goes up, its pressure will drop to P naught minus P now. At the top, at the higher heights, the atmospheric pressure is lower. So let us say the atmospheric pressure at the surface is P naught at the surface near the ground, and the atmospheric pressure at some height will be P naught minus P, let us say. So option number C says that the balloon will expand because it's keep going up and the pressure decreases. See, as the pressure outside decreases, it will automatically expand. I can say that the pressure inside will also be same. So what is happening now actually, the pressure inside balloon is decreasing. Alright. So the pressure is decreasing, that's why the volume is increasing actually. We will see that in higher grades, the pressure into volume is constant if the temperature is constant. So if we say that the temperature is constant and the pressure inside is decreasing, then the volume is increasing. In the other way, we can just say that if there is pushing force is decreasing, then obviously it will expand. So that's why option number B. So option number C we are checking, which is correct. So outside pressure is decreasing, that's why it is expanding. So that's the reason. And option number D says that at higher altitudes it is easier to boil the water. So when the water is boiled actually, see when we heat up this water has its own vapor pressure. This is called as P vapor, let us say. When P vapor pressures become equal to P atmospheric pressure, it will boil. So at higher altitudes, the atmospheric pressure is already less. So that's why we need less vapor pressure. And this less vapor pressure can be achieved at lower temperatures. That's why the water will boil at lower temperatures. Even at lower temperatures, it will achieve the vapor pressure which is equal to atmospheric pressure. And the atmospheric pressure is lower at higher altitude. So we need lower vapor pressure. So we need lower temperature. And the water will boil at lower temperature. So D is also correct. So for 11th, the answer is B because we need to select the incorrect statement. So in this question, we are just seeing that some closed objects are there, and because of the pressure difference, they are either breaking or expanding or contracting, let us say. So that's the situation here. Now the blood coming out of the nose at higher altitudes. So let us say this is the blood vessel. So at the ground, the pressure is P naught for the blood and P naught for atmosphere. But for higher altitude, blood pressure is still P naught and the pressure is dropping now. That's why there is a higher pressure here on this side and the lower pressure on that side. So that's why this wall will experience some force from inside and it will rupture and it will break. So A option is correct, what we are talking about in this question. Let us read the C option instead of B because A, C, D are similar to what we are discussing. Now ink is filled in a fountain pen due to atmospheric pressure. Okay, so it is a fountain pen. Now what we'll do now, first of all, we will press this region where the ink is filled. Okay, and we can call that as let us say some candle of the ink. So when we'll press it, the pressure inside will decrease because we are pushing all the air out. So pressure inside will decrease, and then we suddenly keep it at the normal width, and that's why the pressure will decrease. Okay, and because of that, what will happen, there is ink now, and because of that, because of the higher pressure, the air will try to go inside and it will push the ink also inside. So the ink is filled in a fountain pen due to atmospheric pressure. So first of all, there is an ink candle like this and we press it from both the sides. So what will happen, it will be like this. So there is less number of molecules now, and it will again become a normal with less number of molecules. So that's why the pressure will decrease, and that's why the pressure is higher now at outside and the air will try to rush inside, and that's why the ink will also go inside. So C is correct. Now D says that walking of lizard on a vertical walls. So actually this is the wall, and let us say this is the leg of lizard, and it is nicely packed, and somehow it creates a vacuum. It is able to create a vacuum. So that's why the pressure is lower here and the outside pressure is P atmospheric pressure. So that's why there is a force. The air will try to go inside, but it is packed. So that's why it can't go inside, but there is still the pressure in that direction. And because of that net force, the lizard will get a grip and it won't fall back. So because of the vacuum created inside, the pressure is net, the pressure difference is there, and because of that there is a force on the lizard's wall, and because of that there is a grip and it won't fall back downwards. So D is also correct. Now for B, the things are little bit different. There is still pressure difference, but it is not closed like blood vessel. It is not closed like this this ink, this ink candle, and here also it is closed. The leg is closed and the vacuum is created. But in case of kites, it is something different. When the kites are flying, they are made in such a way that, and the shape is in such a way that the air which is going inside has some higher speed, and the air going above is having lower speed. And we will study in this higher classes that the air going, so basically these kites will move in such a way that, see, the kites will have some mass and its force will be downward due to gravity. So we need some net upward force. So we need, so the kite is stable, so we need force upwards, and the net force should be 0. So let me repeat again. This is a kite, the gravity will act downwards, and the force due to air has to act upwards. Actually, the net force due to air act upwards, and the force due to air and gravity should cancel out, and the net force is zero. So my point was, what is this? The net force due to air. So let's try to visualize this. I'll draw it again, and only due to air I'll try to draw now. So there is a net force upwards due to air. So I can say that there is a more force acting from downside than upside due to air. Alright, so what will happen is, actually, for this kite, the kite moves in such a way that the air on the top will move with fast velocity and the air at the bottom will move with slow velocity, and the air which is moving faster has lower pressure. So pressure is low here and the pressure is high here, and the pressure is high here, that means more force. The pressure is low here means low force. So pressure is higher here, and that's why there is a net force due to air upwards, and which will balance the gravity. But it is not similar to these three cases where our objects are closed, and that's why B is little bit different situation, and B is different from others. So B is the different, and B doesn't demonstrate the things which we are discussing in this blood vessel and this ink candle and this leg of lizard. So B is different, and that's why B is the correct option. It doesn't demonstrate the things similar to this, this and this. So B is the answer. In this question, it says, in the following phenomena, heat is not generated due to friction in which case? The first option says that forest fire. What will happen there? Dry leaves catch fire and the fire spreads uncontrollably. So why will dry leaves catch fire? Because of some wind, some leaves will rub on other leaves, and that's why, because of friction, some heat is generated, and it requires a very little heat to start the combustion reaction, and that's how the fire is generated and it spreads. So A is correct. It is generated due to friction. B is, when you apply brakes for stopping a vehicle, so the tires are rubbing against the road and there is a sliding friction and the heat is generated. So B is also correct. So C says that when athlete runs faster, when athlete runs fast, there is a high friction between their feet and ground, which creates high heat and athlete's body gets heated. This is not correct, because when athletes run, their shoes are not sliding against the surface. It is static friction. The shoes are not sliding. That's why heat is not generated between the shoes and the surface, or the earth surface or ground. So C is wrong, and D is, when a meteorite is about to strike earth, it catches fire and gets burned. This is correct, because when the meteorite is moving through air, because of air drag, it's like air friction, and basically the meteorite is sliding in a fluid called air, and that's a sliding friction then, and that's why the heat is generated. So only in C option the heat is not generated due to friction, because it is a static friction in the third case. In C case, it's not a kinetic friction or sliding friction. So C is the correct answer for this question. In this 14th question, if the explosion happens in outer space, the astronaut in space station can't hear any sound, because for a sound to travel we need some medium, because sound is a mechanical wave. Sound is just vibrations traveling in air. It's basically the vibrations of air molecules. Vibrations travel in air. That is called as sound. If there is no air, then sound can't travel. So in vacuum, the sound can't travel. So if we read the first option, he will see the explosion first and will hear the sound. So he won't even hear the sound. So A is not correct. B option says that he will hear the sound of explosion first. No, he will not hear the sound. So B is not correct. He will see the explosion but won't hear any sound. So C is correct, because sound doesn't travel in vacuum. So that is correct. And D says that he will hear the sound of explosion. He won't hear. So that's why D is not correct. So C is the correct option. In this question, if this is a surface and we keep a coin like this horizontally and we push it, then obviously the sliding is happening between this coin and surface, and the coin will stop. So A option says that friction is able to stop sliding. That is correct, but unable to stop rolling. Now let us understand what is rolling. So in rolling, when you want to start rolling, the friction is necessary, because when you want to turn something, some force should be applied, right? And that force will be friction force. You can imagine some wheel, then we have to apply some force to turn it. So in rolling, that force is provided by friction. So to start the rolling, we need some friction. But when it is moving with normal, like constant velocity, then we don't need any friction, and no friction is acting when the object is rolling. So if there is no friction acting when the object is rolling with constant velocity, then its speed won't be reduced at all. So that's why it is not able to stop rolling. So there is no friction present actually when the object is rolling with constant speed. So A option says that friction is able to stop sliding but unable to stop rolling. So A is correct. B says that friction is unable to act during rolling. So friction is unable to act during rolling, because when we just say that rolling is happening with constant speed, then the friction won't act actually, okay? But the friction is unable to act because of what? Because it doesn't need to act. When the objects are moving with constant speed, it will just keep on going. It doesn't need any friction now. So that's the reason the friction is not acting. The reason it is saying in option B is because it is very less, the contact surface is very less. That is not the correct reason. It doesn't need any friction to roll. That's why the reason is wrong. So option B is wrong. The curved edge surface of a coin is perfectly smooth. No, again, why the friction is not acting in case of rolling? Because it doesn't need when the velocity is constant. It doesn't need it. It is not sliding at all. The condition for rolling is the velocity of this particle A here is zero at any instant. It is at rest. After some time, this particle will come here A, so it will have some speed, but whatever particle is in contact with ground, let us say B, then the velocity of B will be zero. That is the definition of rolling. So basically there is no sliding happening. Okay, so basically there is no sliding happening in this case. uh, so that's why there is no sliding friction, and there is no static friction also here, because if there was a static friction in that direction or some direction, its speed will change actually. That's why there is no friction acting when the rolling is happening with constant speed. So we don't need the friction. Okay, so C option says that because the surface is very smooth, that's why the friction is not acting. That's not the reason, because we don't need friction while rolling with constant speed. That's why it is not acting. So the reason in C is incorrect. Now D says that friction cannot act on rounds. It can act. It's not like that. So if you hold the coin in your two hands from here to here, I can just draw it. Okay, like this. Okay, so this is the coin, and if you hold it here and here without rotating it, if you just slide it by your hand like this, so this A point is here, A point is again here, just keep on moving, A point is still here, then obviously this part is sliding and there is a friction will act there. So friction can act on round surfaces also, because some very small portion of the round is flat only. So D is incorrect. So the correct answer for 15 is A. So we know that electroscopes works on a principle. I'm not drawing the jar and everything. I'll just draw a copper wire and the leaves. Now when you give some positive charges here, it will spread here, and these leaves will repel each other. Now even if you give negative charge here, this negative charge will spread out, and both will become negatively charged and they will repel each other. Otherwise, let us say the leaves will be like this, and if the same charge is there, positive or negative, this is like charges and like charges, they'll repel anyway. So option A says that the aluminum foil leaves of electroscope will go away from each other when a balloon rubbed with dry hair is brought near the copper wire. But the balloon, when is rubbed with dry hair, gets negatively charged. That means this is the scenario. So that negative charge will spread out and they will repel. So A is correct. Now B says that the aluminum foil leaves of electroscope will go away from each other only when balloon touches the copper wire. So not only when balloon, even if we touch the cloth rubbed with a plastic pipe, the cloth is getting positively charged, and you touch the cloth, then it will become positively charged. It will spread out here, and then also it will get repelled. So that's not the only case. The balloon is not the only case. So B is incorrect. Now C says that Uh, when we put the woolen cloth, when we bring the woolen cloth on near the copper wire, so woolen cloth was getting positively charged. So this scenario, so they will get repelled, not attracted. And the option says that when the woolen cloth is touched to copper wire, the aluminum foil leaves of the electroscope will attract each other only when, no, it won't attract any time actually. Whatever charge you put here, it will spread out and the like charges will repel each other, so it won't attract in any case. So D is incorrect. So A option is the correct answer. In this question we have three balloons attached to the end of a glass tube. So in the first case, the option A says that P1 is equal to P2. Now you see, for both the tubes, the height of the liquid is same, but honey is more denser. Anyway, even if we don't think about that, the liquids are different definitely, and the height is same. That means pressure has to be different. So A is definitely not correct. Now B says that P1 is greater than P2. Now the height is same for both the water and honey in first and second case, but the honey is more denser. That's why it has like more weight, so it has more pressure at the bottom. So actually P2 is greater than P1. So B is wrong. C option says that P1 is greater than P3. Now in 1 and 3 water is there, so same liquid, but in first case the height is more. That means more weight of water, so more pressure. So more pressure, that means P1 is greater than P3, so C is correct. And D option says that P2 is equal to P3. Now in both the cases the height is different. Even when the height was same in first and second case, in second case the honey was exerting more pressure. Now in third case water is lowered again. So basically honey's pressure will be definitely more than the third case. So P2 has to be greater than P3. So P2 is not equal to P3. So D is incorrect. So option C is correct for this question. In this question, Ram, Rambo, Sham and Shambhu made a lemon battery. So lemon battery is there and some copper coin is there and some iron nail is there, and we are connecting it this wire and some battery is there. Now you know the lemon is a good conductor, so current can flow through this. Now iron nail and copper coin is also a conductor, so the current will flow nicely. Now they did some modifications. Now what Ram did is replaced all the copper coins with iron nail. So I can remove this and add iron nail. Still, it will conduct. Now, what modification Sham did? Sham replaced all the iron nail with copper coins. So this is replaced by copper coin. Still, it will conduct because this is conducting. This is conducting. So for Sham also it will conduct. Now for Rambo, now what Rambo did is he replaced this thing with a distilled water. He kept this in a distilled water. Now, distilled water is not conductor of electricity. For conduction of electricity, we need some ions. So, in distilled water, there are no ions. So, electricity can't be conducted in case of Rambo. And the third or fourth one is Shambhu replaced all the lemons with apple. So, if we replace the lemon with apple, okay, let us say this is some apple. Now, with apple also, apple has some electrolytes. That's why the current will flow in apple also. That means if we talk about the case of Shambhu, the current will flow. So current will not flow only in case of Rambo. Option A says that Ram's LED will glow but not Sham's. No, Sham's LED will also glow, so it is not correct. B says that Rambo's LED will glow but not Ram. Rambo's LED is not glowing, so B is not correct. And C says that Shambhu's LED will glow, which is correct, but not Rambo's. Yeah, Rambo's LED is not glowing, so C is correct. And D option says that Sham's LED will glow. Yeah, it is correct, but not of Shambhu. No, Shambhu's LED will also glow, so D is incorrect. So option number C is correct for this question. In this question, let us draw the circuit diagram. So there is a switch here. There is a wire, and there is one LED here. I can represent LED with this symbol. and there is a resistance here. There is one more key here, and then we have electromagnet, and then we have a battery. Let us say this is the negative terminal, this is the positive terminal. This is the circuit. Now, if both the switches are on, that means this is closed, then the current will mostly flow in this outer region. The current won't go in this branch because the current will try to follow a path of less resistance, and the more current will flow through this electromagnet, and the electromagnet will be strong if both the switches are on position. So A is correct. So what will happen if switch 1, basically this is switch 1, this is switch 2 now. If switch 1 is on and switch 2 is off, then also the current will flow. Okay, then also the current will flow, but the current will be less. So that's why electromagnet won't be that strong. Plus, if we really want to flow the current, actually, this should be the positive terminal, this should be the negative terminal. Then if you close this, then the current can flow from here to here like this. Because this is the positive terminal of the LED, this is the negative terminal. So this should be the higher potential, this should be the lower potential. So that's why then the current will flow, but the current will be less now because of this resistance here. And that's why the electromagnet won't be that strong. C option says that switch 1 is off and switch 2 is on. So, so switch 1 is off. So basically this is completely disconnected. No current will flow. That means in C option, electromagnet won't even have the magnetic properties because the no current is flowing. Okay, switch 2 is off in the third case in C option, and switch 1 is off. Switch 2 is on. So it will be like this circuit and this and this. It is broken circuit. So basically the current won't flow through this branch, and there is nothing to flow current in this branch also. But anyway, there is no current through this, so no electromagnet. D option says that switch 1 is off and switch 2 is also off. So again, no current will flow and no strong electromagnet. So option number A is correct for this question. This question says that in the above question here, if instead of iron, uh, copper windings are wound around tungsten, so it is a tungsten here instead of iron, what will happen? See, tungsten is not like iron. Iron is a ferromagnetic material which will get magnetized very strongly. But the tungsten is paramagnetic. It won't get magnetized very strongly. So the first option says that stronger electromagnetic will be created, which is wrong because iron is a material which can get magnetized properly, but the tungsten is paramagnetic. It can't get magnetized that much. So A is not correct. It won't be created. A stronger electromagnetic won't be created. B option says that tungsten will not be magnetized and it won't attract iron clips. See, the tungsten will be magnetized little bit. It can't be magnetized too much. So that's why we can say that tungsten will practically not be magnetized and it won't attract iron clips. So B is correct. Now C says that tungsten is ferromagnetic, which is totally wrong because tungsten is paramagnetic. Now D says that the tungsten will melt. So the tungsten won't melt because the current is not flowing through the tungsten. Tungsten is just uh, above the tungsten. The copper wires are just wound, and the current will flow through the copper wires. And for the tungsten to melt, very high amount of current should flow through the tungsten, and its temperature will have to be much more than its melting point, a little bit more than melting point, then only it will melt. So that's why the tungsten won't actually melt. So option number B is the correct answer for this question.